I enter the setup model. Here, we specify which part we want to print. Both available parts are listed. For each, there are two options: unassigned and build part. We select unassigned for build table and build part for the build part. The event option shows a preview of the event series we click, and the View Events window will be shown to us. In the event section, the material deposition event is selected. Except for time and location, the other field is the on and off of the roller, which is marked off with 0 and on with 1. Here we specify the time frame of the event display. Let's go to the file. The time starts from 0, and at the second point, 0.5 seconds have passed. At the beginning, the roller is on and will turn off after 0.5 seconds. This means a coat of powder is added to the table in this 0.5 seconds and is ready to be scanned to create the first layer. Then the roller will turn off, and after that the coat of powder will be scanned to create the layer, and after that the cooling process will be applied. The roller is turned on again in the 5th second, and the second coat of powder will be added. In 5.5 seconds the roller is turned off. Pay attention to the column of X component, which has a fixed value. We have two values in the column of Y component, 1 and minus 0.8, which completely cover the width of the build part. Let's see how these things work in the software. Click on the Plot button to see the details. The red line shows that the roller is on, and the gray line indicates that it is off. I set the end time to 0.5 seconds and click Plot. We only see that the roller is on in the first 0.5 seconds. In the message area, you can see the coordinates of the start point and end point. The material will be added in the Y direction. If we wanted to print the material in the X direction, we should have defined a line perpendicular to this line. I increased the time to 5 seconds. And as you see, we have a layer of printed material because from 0.5 to 5 seconds the coat of powder is scanned and the cooling process is done. You can see that there is only one printed layer, and the reverse cycle is turned off to start printing material again from the previous start point. Now I wait for 0.5 seconds for the second coat of powder to be added. And now I set the end time to 10.5 and the third coat of powder is added. You can see that the layers are printed in the Z direction. Z is the direction of construction. The total time of the event is 45.5 seconds and we have 10 layers. This 45.5 seconds is related to the time step of the thermal and structural model. So the first column indicates the time which starts from 0 and ends at 45.5. The x component is fixed and y is the distance between 2 points that were explained. This column shows the thickness of each layer. Note that the thickness is repeated twice. We have two 0.1 and two 0.2. It's because the roller has swept the coat of powder and turned off, returning to the same starting point with the same thickness to start the next print. But let's go to the event series related to the laser. Here we have the laser powder variable except from the time and location. The laser event series has more points, and it seems to be more complicated. Join me to make it look easier. We have 5 fields separated by commas to form 5 columns. As we said before, the first column is for time. The next 3 columns specify the coordinates of the laser beam. And the last column specifies the power of the laser. As you see, the laser starts to scan the first layer from the time 0.4 seconds because the coat of powder must be added first. So the laser scanning will be started after the first coat of powder is added. Every time we scan and wait for the next coat of powder to be added, and we scan it again. Now let's see how this scan works and which path the laser beam will pass to scan the laser, as we saw for the roller. So expand the model setup from the model tree and double-click on the events. Select the laser event series from this combo box, entering 0 and 0.4 for start and end time in these numeric fields respectively. Then click Plot. As you see, at the time 0, the laser beam is here, which has 0 power, and you can see its coordinates in the message area. After 0.4 seconds pass, it moves here and has the power of 100 watts. You can see its coordinates in the message area, which are according to what we have in this file. And this is the starting point of scanning the first layer. Now let's change the end time according to the file with steps of 0.02 to see what path the laser beam passes through to scan the layer. At the time of 0.66 seconds, the first coat of powder is scanned and the first layer is created. This is the end point of the first layer's scan, and the power of the laser beam equals 0, and that's why this point's color is gray. Let's summarize what happened here. The scanning will begin from the perimeter of the build part. This happens from t equals 0.4 to t equals 0.48 seconds. You can see at t equals 0.5 the scanning of the area of the first layer starts and continue until 0.66. From t equals 0.4 to t equals 0.66, the print of the first layer is completed. After scanning the first layer, the cooling process and adding the next coat of powder is in progress from t equals 0.66 to t equals 5.4. Well, after scanning the first layer, in the next round, the second layer will be scanned, just like the first one. The scanning of the second layer begins in t equals 5.4. The perimeter of the build part is scanned again, and then the area of the build part. By the time of the t equals 5.64 seconds, the scanning of the second layer is completed. You can see that the area of the first layer was scanned in this way, and the second layer was scanned in the direction perpendicular to the scanning direction of the first layer. Well, I advanced the time to 45.5 seconds so we can see the entire path of laser scanning until 10th layer. A couple of notes. First, the red lines mean the laser has power and doing its job, and the gray lines means that the laser has no power and just moving. For example, after the first layer is scanned, the laser just moves to this location to start the next scanning. The second layer will be scanned, and the endpoint of the scan is this location. So the laser moves to this location for the next round. The scan of the next layer will start from this point. This goes on until the last layer. The second note is that the last layer is not scanned completely because that's how we entered the data. Only its perimeter got scanned. This is just a tutorial video, and when you do your own analysis, you must enter your data completely. We have explained the event part of the setup model in detail.